Good morning. Today's lecture is about an important separation technique, that is chromatography, that is widely used for analytical and research labs and also for industry. I will be discussing about the basic principles of the chromatography and some of the classification and some of the examples of the chromatographic technique that is widely used. As we know, almost all compounds of biochemical interest occurs naturally as very complex mixture of components from which they can be separated only with considerable difficulty. Similarly, many synthetic reactions give mixtures of the product, and it is necessary to have a reasonably clear idea of how the mixtures of the compounds can be separated. Therefore, the separation of the mixtures of compounds to give the pure component is of great practical importance in chemistry and related fields. For many cases, the separations of the components can be achieved either by difference in their physical properties or by chemical means. So, there are many simple and commonly used separation methods. For example, we can have something like a mechanical phase separation. So, as we know, very commonly used technique or commonly used method in the chemical laboratory, that is the gravimetric analysis. What we do here is we do the precipitation of one of the component from the solution, then we will filter the precipitate, then we will do several type of the washing, and we will dry the whatever the precipitate what we got, then we will be going to ignite the precipitate with whatever the filter paper what we can have. Then we will be going to calculate the weight of the substance what we got from the as a precipitate. So, this principle is based on the difference in the solubility of the compound that is formed. This is one of the type of the separation we can achieve for the analysis of the compound or whatever the components that contain in a mixture. One is we can precipitate, other we can put into the solution. The other one is the distillation technique, that is based on the difference in the volatility of the compound what we can have. So, it is just like we have the components or we have the mixture of the components that containing different components that have different boiling point. So, if you are simply distilling that one, we can collect the different fractions or different component of the mixture according to their boiling point. Other one is the extraction, that is based on the difference in the solubility of the component in the two immiscible liquids what we can have. So, there are different techniques we can use it for the separation of the component in the mixture. In this lecture, however, we are considering the separation of the components, that is using chromatographic technique. So, as we know, if you are going from the synthesis, separation and characterization, evaluation or identification, the specimen or the scheme that we have the separation and the purification, it is most and very important, because we know what is the correct method. We want to know what is the correct method to separate which is efficiently and fastly the individual component to further. Then only we can go for a good identification or the characterization. Then only we can know about the structure, what it is chemically, what is the structure of the component, and how many number of the components are present in a complex mixture. So, the chromatography, that is the fast and efficient technique that is first introduced by a Russian botanist, scientist. His name is Mikhail Svet. Actually, he was doing some research on the separation of the plant pigment. For example, he tried to separate chlorophyll and other carotenoids using a calcium carbonate as a stationary phase column, and he used another type of the mobile phase, that is called the petroleum ether and ethanol mixture, to elute the different components in the mixture. So, he introduced the term chromatography, that is in Greek, which means color writing, because his experiment was just like a separating the colored component in a plant pigment. Nowadays, chromatography is a very important analytical technique used widely and frequently for the separation, purification and identification of very closely related chemical component in a complex mixtures. Here, the chromatography separates the component in a mixture between two immiscible phases. The first one is the stationary phase, that as we can see, it is a immobile or fixed phase. It can be a solid or it can be a liquid adsorbed on a solid material. The other one is the mobile phase. As you can see, it is a mobile where the sample is just transporting, or it can be flow through the phase. Mobile phase to carry the components along the stationary phase, while the stationary phase is try to retard their movements or slow their movements on the stationary phase. The basic principle of chromatography is the differential distribution of the component between the stationary phase and mobile phase. There are different scheme of classification of chromatography. One is based on the physical state of the mobile phase and the stationary phase what we are going to use. The other one is based on the operational technique what we are going to use. Based on the mechanism of the separation, it can be further classified into various categories. So, we will go to the details of each categories in the further sections. So, the most basic method of classifying chromatographic technique involves the specifying the physical state of the phases that is used. So, that is the mobile phase and the stationary phase where we are going to use. Here we can find out the different classification. For example, if you have a mobile phase that is a liquid, and otherwise we can have a mobile phase that can be a gas. So, we have a liquid and gas chromatography based on the physical state of the mobile phase. Another is the based on the physical state of the stationary phase. Either we can use a solid stationary phase or we can use a liquid stationary phase. So, if you are classifying these two together, mobile phase classification based on the liquid and the gas phase, and stationary phase that is on the solid and liquid, we can have 4 type of the combination here. The first one is the liquid mobile phase and the solid stationary phase, that what we call liquid solid chromatography. Otherwise, we can have liquid mobile phase and we have a liquid stationary phase, that is called a liquid chromatography. On the other side, we have a gas as a mobile phase, then we are taking 2 type of the stationary phase, one is the solid and other is the liquid. So, 2 types of the category for the gas chromatography also we can see, that is the gas solid chromatography and gas liquid chromatography. So, the techniques liquid solid and liquid are collectively called as commonly, or we can say commonly called as liquid chromatography generally, and the other technique that is gas is used as a mobile phase. We have the 2 combinations, gas solid and gas liquid, which is collectively called as gas chromatography. Based on modes of the polarity of the mobile phase and the stationary phase, we can further classify these into 2, that is normal phase chromatography and reverse phase chromatography. Normal phase is the terminology used when the stationary phase is polar. For example, we can have silica gel support, and the mobile phase is less polar organic solvent or a mixture of the organic solvent. Here that means stationary phase is a polar and the mobile phase is a non-polar things. However, in the reverse phase chromatography, the stationary phase is a less polar. For example, we have the silica bonded stationary phase that is coated, or we can attach it with some of the substrate that contain the long chain aliphatic groups, or we can have a non-polar group just like a fatty acids we are attached there. For example, you have a C18 column, that is modified silica gel column is modified with an aliphatic group or a non-polar group, that is called the reverse phase chromatography. So, here we are using a less polar stationary phase and we are using a more polar mobile phase, that is to elute the sample from the column. As we noticed before, the mobile phase try to carry the component along the column. The process is called elution, and we have another thing, that is the solvent used for eluting the sample, and the solvent is called the eluent. So, based on the elution, again the chromatographic technique is classified into 2 categories. One is called the isocratic elution and other is called the gradient elution. In isocratic elution, what we do here is that we are using a single solvent to elute the sample out of the column. So, only the single solvent is employed in isocratic elution, or we can have a mixture of the solvent that have a uniform composition throughout the elution of the column. But in the case of the gradient elution, we are using more than one solvent. It can be a 2 solvents, or it can be a 3 solvents or 4 solvents, etc. That is, we can use a mixture of the solvent here we are going to use. So, it is just like a gradient elution. We are changing the composition of the solvent 1, 2, 3 or 4 accordingly during the elution throughout the column. Another type of classification is based on the scale of the separation. So, it can be categorized into 2. One is the analytical chromatography and other is the preparative chromatography. As the name says, we know analytical is just like we are going to do an analytical scale. So, we are to just separating and identifying the component what it is coming throughout the chromatographic column. In the next case, we are doing a preparative separation, that is we are collecting in further high quantities. So, what we can do here is instead of just analyzing, we can collect the separated components and we can analyze further it with the coupling with another type of the identification techniques just like a spectroscopy or other type of any of the thermal analysis method, etc. So, we will get more information about the individual components what it is separated by the chromatographic technique. So, based on the another type of the classification is based on the mechanism what we are using in the type of the chromatographic separation. So, the most important one or the first one is the partition chromatography and the other one is the adsorption chromatography, and we have ion exchange or ion interaction chromatography. Then another one we have the size exclusion chromatography, and last one we have the affinity chromatography. We will go through the details of the each and every one. First one we have the partition chromatography. Here the separation is based mainly on the difference in the solubility of the sample components between the 2 phases, that is the stationary phase and the mobile phase. As we can see in the figure, here we have a stationary phase, that is a liquid coated on a solid substance. That is, we have a stationary phase, that is a solid support is there, a liquid is simply coated over the solid support, that's we are using as a stationary phase. Just like in any chromatography technique, we have another liquid or another solvent that will be just simply flowing through the solid surface, or what we can have the stationary phase, that is the mobile phase. So, according to the relative solubility of the sample components in the stationary phase, more readily or easily soluble component in the mixture will go to the liquid stationary phase coated over the solid support, and their movements will be retarded in the stationary phase. So, as we can see here, so the components that are more easily soluble in the mobile phase will be just flowing with the mobile phase, but which are not that much easily soluble in the mobile phase, while it is more soluble in the stationary phase, that is the liquid adsorbed on the support that will go through that one. So, as we can see, as the separation proceeds, there is a difference in the concentration of the sample component between these two phases, that is, one is the liquid flowing, that is the mobile phase, other one is the liquid coated on the support, that is the stationary phase. So, due to this difference in their solubility, some of the sample it will be going through the mobile phase, other is just sticked onto the stationary phase, that is the thin liquid film over the solid support. So, after the elution, whatever the component that are easily soluble, it will be simply flowing through the mobile phase. Then after some point, the concentration of the component will be less in the mobile phase. So, what is going to happen is, here the sum of the component from the stationary phase, that is in the liquid coated over the solid substance, will be passing to the mobile phase. So, there will be a concentration gradient, it will be going to set up inside or in between these two phases. Because of this one, the component will be simply flowing through the mobile phase. We can get a nice distribution of the component according to their solubility in these two phases. So, therefore, the distribution of the sample component between mobile and stationary phase can be described simply. As you can see, the concentration of the sample in the mobile phase will be reaching an equilibrium with the stationary phase. So, the simple repeated movement of the component between the stationary phase and a mobile phase. For an unlightened equilibrium between these two phases, that can be given by a simple equation, that is called equilibrium constant Kc, which can be given as Kc is equal to Cs divided by Cm, where Cs is the concentration of the unlight in the stationary phase and the Cm is the concentration of the unlight in the mobile phase. It is just like a simple distribution between these two phases. So, the equilibrium constant, that is termed as partition coefficient, that is very important in chromatography. It is defined as the ratio of the molar concentration of the unlight in the mobile phase to that of the component in the stationary phase. From the expected mechanism shown in the figure, the separation is based on the principle that the different component in a mixture can have different partition coefficient for a given set of immiscible mobile phase and stationary phase. Therefore, the components get distributed themselves to different extents between these two phases, thus they move at a different rate, which results in their separation. That means, the component with the highest Kc value, or what we can say, the component with the highest partition coefficient will spend more time in the stationary phase, we can say it is retarded by the stationary phase, emerges out of the column at last, or we can say it takes long time to elute throughout the column, but those components we can have a lower Kc value or lower partition coefficient will be just simply flowing very fastly. So, we got nice separation between the component, one is moving very fastly, another component is moving slowly. So, we can separate the intermediate, that is moving intermediate speed can be separated in between these two. So, we got nice separation of the different components from a complex mixture. Partition chromatography was first introduced by scientists Martin and Sinjay in 1941. They tried to separate a mixture of acetylated amino acids by using water coated on solid silica gel as a stationary phase and chloroform butanol as a mobile phase. They were later awarded for the Nobel Prize for this work they are doing. Major application of partition chromatography includes quantitative separation and identification of organic and inorganic components. Then we can have the purification of the product of chemical reaction in an analytical and preparative scale for the laboratory and both industry as well. Next one is the next mechanism is the adsorption chromatography. Here the separation is based on the selective adsorption of the sample component on the solid adsorbent like silica gel, alumina or cellulose or graphite etc., which constitute the stationary phase. Here the mobile phase consists of a suitable solvent like petroleum ether, acetone, benzene or any other organic solvents. As shown in partition chromatography, each component will try to equilibrate between the stationary phase and the mobile phase. However, the major difference in the adsorption is that each component will under the influence of two opposing forces. So, first one is a retarding force in the form of a selective adsorption upon the solid stationary phase, and the second one is a driving force in the form of a flow of the liquid mobile phase, which try to take the component along with the mobile phase. So, the net effect is the differential migration of the components along the column of the stationary phase that causes for the effective separation of the individual components from the mixture. Therefore, in the adsorption chromatography, the component most strongly adsorbed to the stationary phase emerges out of the column last. Those not adsorbed will comes out the first. So, those can have intermediate interaction, weakly adsorbed or more adsorbed will be coming or eluting in between. So, as you can see here in the stationary phase, the components are adsorbed there, that is we can see as given here. We have the some of the component adsorbed on the stationary phase that will be sticking on the stationary phase, it will not come out first, and those who have a weak interaction, it will be coming very fastly with the whatever the eluting or whatever the mobile phase we are going to use. In this way we can get the separation of the strongly adsorbed, moderately strongly adsorbed and very weakly adsorbed, etc. We can get the separation of the components into individuals. In adsorption chromatography, a solution of the mixture of the components in a suitable solvent is introduced into the column. Then the mobile phase is continuously pumped throughout the column. This process is called the elution, just like in any chromatographic technique, and the solvent here usually is called as the eluent. So, as the mobile phase percolates over the adsorbent stationary phase, the component will get separated according to their interaction adsorption capacity and will get separated within the column. So, the sample component which do not absorb will come out with the mobile phase can be separated firstly and very easily. The other component that is eluted by using suitable solvents or combination of the two or more solvents called a gradient elution. That means just like a binary mixture of the solvents or a ternary mixture of the solvent or even a quaternary solution can be used as a mobile phase for the complete and efficient separation of the components according to their interaction on the solid adsorbent as the stationary phase. The factors that affecting the adsorption of the sample on the surface of the solid stationary phase mainly includes the nature of the sample component. For example, we can have maybe a polar components or polar sample components and a non-polar component, polar sample components. How we can going to separate that one, it will affect the separation. Then we can have the chemical structure of the components. For example, we can have the same chemical formula or same molecular mass, we can have different type of the isomers that we can be separated. Then we can have a linear components maybe of the same molecular weight, we can have something like a branched structure that also can be separated. Then we can have the bulky structure or we can have a bulky side group on the main chain that will contribute some of the steric interests. Mostly in the case of the adsorption chromatography, the molar mass have a little effect, but we can have a very slight separation according to the molar mass in the case of the adsorption chromatography, but here is basically mainly based on the adsorption or the chemical structure of the component what we can have. For example, we can have a separation of the mixture of the orthonitroaniline and paranitroaniline that can be separated on an alumina column, that is the stationary phase, by using benzene as the mobile phase. So, weakly adsorbed orthonitro compound come out first during the elution due to the steric hindrance of the nitro group in the ortho position. Adsorption chromatography is the most widely used technique for the efficient and fast separation, identification and purification of the samples in the laboratory and many industries. Major application of the adsorption chromatography includes quantitative and qualitative separation of similar organic component in a complex mixture. Then we can have the purification of the organic components. Then concentration of the solutes from the dilute solution we can determine by the adsorption chromatography, separation, purification and identification of natural products that we have the similar chemical structure or closely related chemical structure. Then both analytical and preparative separation of the industrial product also can be done by using the adsorption chromatography. Another important type of the mechanism that is used in the chromatography is the size exclusion chromatography. Previously it was known as the gel permeation chromatography. It is a mechanical sorting of the molecule according to their size, or we can say molecular mass or molar mass or molecular weight. Here the stationary phase is a solid particle that consists of micropores. Small molecules can have access to the stationary phase, or small molecules can have access to these small pores on the stationary phase, and it can reside there for a long time, and other molecules just like a bigger size can be excluded that cannot have access to these small pores. So the extruded or large molecule will flow out with the mobile phase followed by the medium size or the smaller size one. So in this way, the distribution of the molar mass of the different components can be achieved by size exclusion chromatography or gel permeation chromatography. Therefore, the SEC or SEC is mainly used for the analysis of the samples having varying molar mass or molar mass heterogeneity or molar mass distribution. Here the actual separation occurs according to the hydrodynamic volume of the molecule what we can have. Hydrodynamic volume is the sum of the average of the molecular volume and the volume of the solvent molecule associated with the molecule. So as I told before, here in the column or the stationary phase, it consists of the particle that have some of the small pores. So if the mobile phase is flowing through the column or the stationary phase, these pores will be contained the mobile phase. So the volume of the mobile phase that is occupying the small pores of the stationary phase, that is called pore volume. As we know, only the small molecule can have access to these pores. The other volume what is occupying is the space in between these stationary phase particle, that is called the void volume. So as we know, or as we noticed before, we can have the bigger molecules will be just flowing through the void volume, but we can have the small molecules that will be going through the pores of the stationary phase what we can have. So as in the case of the partition chromatography, when the molecules start to elute, so we can say the larger molecule, they don't have access to the pores, so it will be simply flowing through the mobile phase, it will come out first, or we can say elute first. So if the larger molecule has gone through the mobile phase or the solvent what it is flowing through the stationary phase, there will be a decrease in the concentration of the sample in the void volume. So what is going to happen is the samples that is, or the molecules that is sitting inside the pores, it will just come out through the mobile phase. So there will be again the repeated movement of the molecules between the mobile phase and the stationary phase. This will conduct, or this will constitute a concentration gradient. So those molecules in the pores comes out in the mobile phase to the void volume and eluted by their repeated movements between the pores in the stationary phase while coming down through the column by the mobile phase flow. So SEC is mainly used for the separation of the large molecules just like proteins, macromolecules and industrial polymers etc. to determine their average molar mass and their and the molar mass distributions. So as you can see, I have given one of the examples here. We have the samples containing the different balls or the colors of the different balls. It tell about the chemistry of the sample, and the size it will tell it is of the different size. So as we can see here, we here separate according to the size, not according to the chemistry. That is one of the limitation of the size exclusion chromatography. We can get the separation according to the size, or we can say according to the molar mass of the component, not on the chemical structure of the component, and that's only we can determine the size or average molecular size. Normally we say in the case of the size exclusion chromatography, and industrial components or industrial samples just like polymers, we can say we will determine the average molar mass and its distribution, or we can say the heterogeneity, molar mass heterogeneity that present in a commercial sample etc. The other mechanism what we use is the ion exchange chromatography. The stationary phase here used is an ion exchanger, and the distribution of the component of the mixture is based on the ion exchange principle. Mainly, as we can see from the name itself, this is mainly applicable for the separation of the ionic species. For example, we can have two types of the ion exchange chromatography. One may be cationic exchange chromatography and other may be anionic exchange chromatography. So just like any chromatographic technique, here we can also have a stationary phase and we can have another mobile phase as well. Here the stationary phase, for example, depending upon the sample what we are going to choose the separation. For example, if you want to separate a anionic species, we have to choose for a cationic separation, cationic stationary phase, or we can say a solid support that is attached with some of the cationic species that can interact with the, that we can attract the anionic species. In this way we can get some of the retardation of the anionic species on the stationary phase. Rest of the component it will be simply flowing with the mobile phase. So in this way we can get the separation according to the charge, or we can say according to the nature of the component what we can have. So we will selectively separating the anionic species from the sample mixture. So ion exchange chromatography is a reversible chemical reaction where ions from the solution is exchanged for a similarly charged ions that is attached to an immobile solid particle, that is we call a solid stationary phase support. ion exchange particles are either naturally occurring, or we can say, or we can produce that by synthetically. So among the synthetic, we are using the insoluble high molecular weight cross-linked polymeric resins with porous structures are the most commonly used stationary phase that is used for the separation of these type of the either cationic or anionic species. The next one is the mechanism is based on the affinity. The principle is based on the specific affinity between the molecules to be isolated, and the molecule it can be immobilized on the stationary phase. As you can see, just like here, one kind of the molecule in a complex mixture become attached to the molecule that is covalently bonded to a stationary phase. Here it is simply just like a lock and key method. So one of the particular component he is going to lock onto the stationary phase, all other component that will be simply flowing with the mobile phase what we can have, or it is simply fastly eluting with the mobile phase, other is going to stick on the stationary phase. So by using different type of or combination of the mobile phase, we can simply detach the whatever the attached component to a particular phase on the stationary phase. During the affinity chromatography, the interacting partner of the molecule called ligand is immobilized on a chromatographic resin. This ligand fixed to a stationary phase reversibly bind the desired molecule present in the multi-component mobile phase, or we can say different component that present in the mixture of the complex mixture. So the material can be eluted from the column by changing the composition of the mobile phase, as I told. So either we can use another type of the mobile phase, or we can use a mixture of the mobile phase to elute whatever the component attached here. By affinity chromatography, high selectivity separation of the biomolecules can be achieved through their specific interactions. This separation technique is special because it is based on the biological function or the unique chemical structure of a given biomolecule. So basically many of the biomolecules can be separated by using this type of the affinity chromatography. So in this section, we discussed about the principles of the chromatography and some of the type of the classification that is mainly based on the physical state of the stationary phase and the mobile phase. Then we discussed about the different mechanism that is involved in the chromatographic separation, that is includes the partition, adsorption, size exclusion, ion exchange and affinity chromatography. I hope you enjoyed this chromatographic section, introduction part. In the next section, we will be going to discuss the another type of the classification based for the chromatographic separation.